Hi, welcome to my video on part 10, composition of functions, and this is number 8 in the composition of functions. I have a problem that I've made up. A right cylinder has its diagonal 4 times more than its height. The surface area is 80 pi square centimeters. Find its exact volume. Well, we have a right cylinder, so let's draw a right cylinder. Right cylinder means that the base is perpendicular to, the height is perpendicular to the base, and there's a right angle. And the diagonal, says the diagonal is 4 more than the height, so the height plus 4. The surface area, SA, is 80 pi centimeters squared, and it says find its volume, so we got to find its volume. So if we have the diagonal and the height, so this is the height, and this is the diameter, which is twice the radius, and the diameter, the diagonal, I keep calling the diameter. The diagonal of a right cylinder goes from the top to the bottom, passing through the center. So this is the diagonal of a right cylinder. It goes from top to bottom, going through the middle of the cylinder. And as a result, we have C squared is A squared plus B squared, and D is the hypotenuse, A is the height, and B is 2R being squared. So we got D squared equals H squared plus 2R all squared is 4R squared. So we have the diagonal, height, and radius. But the diagonal is 4 more than the height, so that means that H plus 4 can go into place of D. And now we have an equation with H and R. So let's square the left side. So H being squared, product 4H doubled, 8H plus 16. And we got the right side done. The H squared cancels because it's on each side. And we can solve this for R. Let's solve it for H. Make H a function of R. So 8H equals 4R squared minus 16. And divide by H, divide by 8. 8 divided by 8 is 1. 4 divided by 8 is a half R squared. 16 divided by 8 is 2 minus R. So notice now we have the height as a function of the radius. So the height is a function of the radius. But we have a surface area. The surface area of a cylinder is 2 bases, 2 circles. So it's 2 pi R 2 circles, so that's 2 pi R squared, plus it's the lateral area. And the lateral area, when you take a cylinder and cut it down like that, the lateral area, this circumference here that's the circumference, which is 2 pi R times the height. So the lateral area is 2 pi RH, because when you cut this down here and fold it out, you get a rectangle. That's how I remember. So there's 2 circles and a rectangle. But the surface area is 80 pi. 2 pi R squared plus 2 pi RH. Notice now we have R's and H's. So if we have H, if we take the H and replace it, so 2 pi R squared plus 2 pi R, and we make H 1/2 R squared minus 2, and we simplify this equation, so we have 80 pi equals 2 pi R squared. and we multiply 2 times a half is 1, so we get a pi r cubed. And 2 pi r times negative 2 is a negative 4 pi r. Notice now we have only one variable of r. So if we put this in descending order, we have, let's go down here and get more room. So we have pi r cubed plus 2 pi r squared minus 4 pi r. And we bring this 80 over to make it a minus 80 pi, and that equals to 0. So instead of swinging them all this way, I just brought that minus 80 pi this way. So we got r cubed, r squared, r, and a constant. Notice that pi is in every term, so we divide by pi. We get, that's an r cubed now, see? Got to be careful. That's an r cubed plus 2r squared minus 4r minus 80 equals 0. So we have an equation with r in it. Notice a cubic equation, r cubed. So that means we have 3 roots. And 3 roots, if we have 3 roots, it could be 3 real roots, or it could be 1 real and 2 imaginaries. So how do we go about it? Well, if you looked at the unit on polynomial equations, then polynomials, we solved the cubic polynomial, we solved the quadratic, quartics, and quetics, and we did it by using the factors. So it's all the factors of 80 divided by 1. So we have 1 times 80. We have 2 times 40. And we have more factors. We have 4 times 20. We have a 5 times 16. And we have an 8 times 10. So we have all the possible factors of 80, but which ones fit? So the fastest way, rather than plug in one at a time, we'll do synthetic division. So notice this is real roots. R is real, so therefore the R has to be positive. So we don't have to look at any negative factors to work out this root. So they're all positive. So let's do what we call the topic of synthetic division. Let's take 1 and go into 1, 2, negative 4, negative 80, doing synthetic division. Draw a line, bring down your 1. 1 times 1 is 1, add 3. 1 times 3 is 3, add negative 1. 1 times negative 1 is negative 1, negative 81. So that's the remainder. That remainder is not 0, so 1 is not a root. Now let's try 2. 2. So we got 1 gone. Now we're going to do them in order. Somewhere along the line, we're going to pick up one of these. So we got a 1, 2, negative 4, negative 80. And again, bring down your 1. 2 times 1 is 2, add 4. 2 times 4 is 8, add 4. 2 times 4 is 8, and we get a negative 72. So the remainder is not 0, so 2 is not a root. So let's try the next one. 4. 1, 2, negative 4, negative 80. Bring down your 1. 4 times 1 is 4. Add 6. 4 times 6 is 24. Add 20. 4 times 20 is 80. Add 0. So when there's a 0 remainder, that means that 4 is a root of this equation. That means that we have one of the answers. Now we have to check the depressed equation. So we have to look at x squared plus 6x plus 20, which is a quadratic. And so to look at this equation, we will look at the, I say x, but it's really, I'm used to putting x in, but let's put the r here. I'm used to putting the x's in. I slipped the x in by mistake. This is r squared, depressed equation, r squared plus 6r plus 20. So that means the r is, the quadratic formula is the negative b plus or minus the square root of b squared minus 4ac all over 2a. And so that's b is 6, so that's negative 6 plus or minus. B is 6 minus 4. A is 1. C is 20 all over 2 times 1. So that gives us negative 6. That's a 1 there. And this is 36 negative 80 all over 2. And that becomes negative 6 plus or minus the root of a negative. And that's 44 all over 2. And notice this is a negative number. That's an imaginary. So therefore there's no other real root. Because that's a negative, then these will be imaginary roots. But we can only have 4 as a root. So if 4 is a root, then we take this equation right here, h equals 1/2 r squared minus 2. The height is a function of r, so we put 4 in and work it out. We get 1/2 of 16 minus 2, that's 8. 1/2 of 6 is 8 minus 2, and so the height is 6. So the radius is 4. The root is 4, so that means the radius is 4. I got to be careful now. The r radius root of the equation. So the volume is pi r squared h. So the radius is 4. And the height is 6. So that's 4 squared is 16, 6. So that's 96 pi. And its volume, so it's in centimeters, so it's cubic centimeters. So I thought it was an excellent question because you had to use the composition of functions. To get the volume, you need the radius and the height. And so this formula here gave us the height and the radius, but it never gave me. So I had to go through the surface area to get all r's, to do the synthetic division to get 4 as a root, and then I showed that there was no other. And as a result of 4 being a root, we got the h, and then we worked out the volume. An excellent, excellent question. There's a lot of high-powered math in that question. And it's good to do some problems that brings the math and other topics into play too. That's what math is all about. The more math you use, the more math you know, the better you become. That brings us to the end. If you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.